Hello everyone. Today I'm going to show you application I have created long time ago um, by using AWS Serverless. And I'm going to show you how we can learn from serverless and why do we use serverless. So as you see, um, I want to build an SaaS application that is I can control the EC2 instance and also RDS. So as you see, we have a web application. It can be working on mobile as well. So if I do sign in to the application and let's do login, and I bought my credential. So as you see, first Lambda takes a little bit time until get some data. So as you see, we get some information about the EC2 instance. Yeah, I can start or stop the instance from here. I can create new schedule for instance. So the idea is I create the name of an instance and then the provider, if it's AWS, and which service, EC2 or RDS, and the instance ID, um, and what action I need to do. For example, stop or start the instance, and then which region this instance is located, and do I need to get email notification? So if yes, okay, this will sending me an email saying, hey, your instance is start or your instance is stopped. And here the access key and secret key, I'm going to show you how we also save it in DynamoDB, and also how we protect it. Yeah. And which time do you need exactly the instance to start or stop? Yeah, in UTC time. Yeah, and especially you can choose which day is. Maybe you need to stop it every day, and then you can add the record. Once you do this, there is a schedule is running every hour and see for each record if this instance should be start or stop. Yeah, it also can be working with the RDS. So as you see, I wrote an article and you can follow the steps how to clone the repo, and also you can create the table, DynamoDB table, and also creating a Cognito service, and so on. Yeah. Also how to create the bucket, and also putting the JavaScript and HTML in the by using CloudFront also. Yeah. So every details is here. In the end, you will deploy your application in your own account. You can use it in your site, and of course you have full control of it. Yeah. So if you need to see the code itself, you can go to in the GitHub and also you see the code. The application is using Flask, and I'm using Zaba to deploy the Flask application into Lambda, and also it's creating the API gateway. You have everything is here, models for the DynamoDB table, and routing for the routes. Yeah, and also we have a schedule Lambda, because this Lambda, there is another Lambda, as I'm going to show you in the application architecture. The second Lambda or schedule Lambda is starting each hour to check if there is any instance should be start or stop. So as you see here in the architecture, user in the first time they log into the CloudFront, and the CloudFront has origin of S3 bucket for HTML and CSS and JavaScripts. So you can do sign up first time, and then when you're doing sign up, you register incognito. You have your user there and your password. Yeah, and after you sign up and you do sign in, once you do sign in, you get the GWT token from Cognito, and then you can talk to the API gateway. Once you're talking to API gateway, you can API gateway make sure it's checking your GWT token is valid, and after that it will goes to Lambda to get your request. For example, if you want to create a new record in Lambda um, as our backend, we're checking your user, and then of course we have GWT token is valid, then Lambda will get your user and then add your details in DynamoDB table. Yeah. And for schedule Lambda, the second Lambda has CloudWatch. Right now they name it Event Bridge Schedule, and this Event Bridge Schedule is starting schedule Lambda, the second Lambda, and for each hour, and checking the DynamoDB table who is um, want to start or stop the instance. Yeah. As you see, we have KMS. KMS here we use it as when we saving data in Lambda, for example, the access key and secret key. It's especially secret key is use KMS to encrypt the data. There is a better way, even not using KMS. You can using what's his name um, uh, assuming rule. So you can assume rule for Lambda, and this assuming rule without KMS, you're giving access to the assume rule. The user who has start or stop policy, it should has limited access only for start and stop is to an instance. You don't give any more access. You don't need admin or anything else. You just start and stop access. Yeah. As you see here, we have SES, simple email service. It's used to sending notification to the user. So imagine you need to know when your machine is up or when your machine is down. So you get some information here. Yeah. Um, so let's start it. So if we have here, and you see if I do refresh, this is invoke Lambda function, and Lambda function already I logged in, and it's getting the data. Lambda get data from DynamoDB table, right? If I do, as you see here, in instance, it's all stopped. So if I do refresh, it's still stopped. If I go here again in the application and do, okay, I want to start this jump server, or I want to start this web server, or do something. So when I do start, okay, it's asking me, do you want to start it? Yes, I want to start it, this node. And it gives me, okay, current status pending, um, previous state is stopped. So it takes a little bit time, but if I do refresh here, it should be initializing, and then, okay, it's running now. And as you see in this instance was last 532, and here 532, the instance ID. This also, it can be start and stop here, but in this is not the idea only. The idea is to stop by scheduling, yeah? So once you're adding here and you give the action to do, stop or start, the instance will be do this action, yeah? Um, let's see what's in the Cognito. As you see, I used also you can have you can get access by also external provider, for example, like Facebook, yeah, or I can use Cognito to log in, yeah. So as you see, where is Cognito? This is users, yeah. This Cognito, you have your app client. You can do sign up. Right now I disabled sign up registration, but yes, you can enable it if you want external users to sign up. And most of the domain things in Cognito, you have your custom domain and your users and the app client you added. Yeah, so in the article you see all steps to create this Cognito. Yeah. Um, Second thing, if we go in the application itself, the architecture, we see API gateway. So let's go to API gateway. This Cognito, this event bridge, this API gateway. So in API gateway, we have this instance scheduler. And as you see, we have any request, for example, uh, get, post, delete, anything, it will using authorization, this sub authorizer. So if we click in here, it's using the Cognito, Um, as you see, this is a Cognito authorizer, yeah, the same ID. And so any request asking for GET or request, it should has authorized by Cognito to make sure the authorized user has getting the data, right? This options is using mock because you don't need this CORS issues coming in the browser, so you need to use this options method. And once you do any request, then I will do integration here. You see the Lambda function that is be invoked by API Gateway. API Gateway has maximum timeouts 29 seconds. So you need your function, as you see here, um, you need your function be response before 29 seconds. Otherwise, it will give the user 500 error. Yeah. So once we open this Lambda function instance scheduler staging, you see the code. Yeah, it's as you said, it's Flask, and as you see, there is some environment variable. I put it in configuration here, and what is the table name, which region, which KMS ID, and what is the secondary global index for DynamoDB. I'm gonna give you details about what we have in DynamoDB. And so in the code itself, you can the application gets some routes if it's need to get EC2 information or start RDS or stop RDS or sending webhook notification to Slack, for example. You can have an account here, and you can enable webhook if you want to enable it or disable it to send you a notification in Slack. Yeah. So um, this is the Lambda function is okay. This is the second Lambda function. This is the first Lambda function. Okay. This is the second Lambda function that is I show it in the beginning. In here, this schedule one. So this is schedule one. This is the one with staging, the one we needed here. And as you see here, the models for database for DynamoDB, and here the auth. Yeah. And as you see here, this is how we can get token email, because when the user is doing authentication, then we can get some information about the user. Yeah, we want to get the email of the user. And notification, you get sending notification by email, and routing here is all for routing to get EC2 instance information, get or post or doing an action. Yeah. Um, the second Lambda is the Lambda daily one. The one is what we say is scheduled each hour. This Lambda function is getting the global secondary index from DynamoDB to get all users that is configure timing, and check each record if this record needs to start or stop instance. Yeah. So let's go to, okay, we finished with API Gateway. Let's go to DynamoDB. And as you see, each record, if we adding a record, it's creating in a specific time and which days you need to be enabled, for example, and the title and to do, for example, stop or start, depending what do you need, and which profile or access key and secret key. The important thing here is the time. This is the secondary global index, yeah? So if we go back and do filter and do by time, and we say the time equal to 00, oh, yeah, 00. So it will be giving all records in one query who configure the timing for the instance to start or stop in a specific time. So you can get all users. Right now I have only one user, but I can have multiple users at the same time. Yeah, I can get, yeah, the idea for global second index is to query, and then you get all users that is the same the same timing you need. So for example, 1 o'clock, if you if your Lambda function start at 1 o'clock, then it will get all user that is configure did time at 1 o'clock. So that's meaning then your Lambda will check is this user needs to start or stop or doing is this user need to stop or start depending or send a notification. And once it's done with this user, then it goes to second user and yeah, and so on. So this is how DynamoDB table is configured. Um, so instance schedule, you can see the index here as a global secondary index, and you have partition key with the email and sort key with the created. So you can have, as we see before, you can have um, the same user partition key and sort key with a different ID. So you can have the same partition key as an email and with different sort key. So, and you can calling when we design the application, we say, okay, what is the access patterns? So, for example, we need to get all user information by one request. Yeah, was one. So we do this with partition key. So when I go in the beginning of the application, the first time I do like here instance schedule, it gives me all data for this user, right? So I'm asking with one query with the email address with the partition key, hey, give me all data for this user. It's give it to me, right? And when I want to delete a record, I can delete it by partition key and sort key for this special record. Yeah, so I can delete it, and then it will be removed from DynamoDB. So what else we have? KMS, as we said, is we use it to encrypt the secrets, and yeah, um, that's it for the application. If you have any idea, um, or you want to do some enhancement to the application, just let me know on in social media, and yeah, we can do this. Or you can you can get cloned for the application, do pull request, and then we can change the UI or do something. But the application is fully open source, and in this article you find all information you need to create the application in your environment. Thank you very much, and have a nice day. Bye bye.